Hello, Jackie. Let's blast through this kind of fast. I'm in between classes. Maybe I can get this. So for 16, the time spent commuting from home to work for all employees of a very large company has a normal distribution. That means we can draw the picture with a mean of 42. We should put the 42 right in the middle, much like the problems we did earlier, and a standard deviation of 12. Okay, so there's this guy here and this guy here. The mean of time spent commuting from home to work at a sample mean for a sample of 16, so n equals 16 employees of this company. All right, anytime we have an n, this indicates that it's a chapter 7 problem. Anytime we have an n, that's chapter 7. That's worth making a little note for to yourself to remember. So maybe we should erase these two guys. Now, we really didn't have to erase the mu because mu sub x bar is mu, right? Mu sub x bar is mu, which is 42. But sigma sub x bar would be sigma over the square root of n, right? And in this case, that would be 12 over the square root of 16. 16 is too small unless the original material is normal, but we see here that it is, so we're good to go. All right, so the mean of time spent commuting from home to work of a sample distribution of a sample mean for, wait a minute, there's more to this. I don't see the instructions. Without instructions, I don't know what to do. I'll have to go look at this. Maybe this might be a bad problem because there's no indication that we're to do anything. We can do it because the original material has a normal distribution. If you wanted to know what the chances of it taking more than 50 minutes or less than 30 minutes were, you could put that on here and figure it out. But there's no question. So I'm stuck on this one right there. Okay, let's go look at the next one. 40%. That's all we have to know that we're probably dealing with a p-hat type problem because of the proportion of all students at a large university live on campus. Suppose a sample of 100. Okay, so p equals 0.4. Not you, it's p because the percent, it doesn't say anything about a mean or a median, so this is going to be a p-hat. But p is what we're given, that's the first impression. So 40% would translate to 0.4. Sample of 100 would be n equals 100. Is selected from this university, and the sample proportion, another key that we might be dealing with a p-hat, is defined as the proportion of students in this sample who live on campus. That's what we were talking about here. The standard deviation of the sampling distribution of this sample proportion is, the formula for the standard deviation of p-hat is pq over n, but the square root of all that. So this would be 0.4, and q, of course, is the complement of p, so that would be 0.6. N is 100, and it's the square root of all that. So going to our calculator, we'd get our square root function, 0.4 times 0.6 divided by 100. And it looks like approximately 0.049. That's about what we would get. That looks like a good answer to me. Round it to whatever you need. Suppose the proportion of elements of a population that possess a certain characteristic is 0.6. Again, 0.6 is a p-hat type problem, so it looks to me like p equals 0.6. This condition is met. The probability that the sample proportion for a sample of 100, so n equals 100, is between these two values. Okay, so we have a situation where we would draw our graph. Mu sub p-hat would be p, which is 0.6. Sigma sub p-hat would be that formula we just used, so that would be p is 0.6, so q would be 0.4 over n would be 100, and it would be the square root of all that. But we want to be between these two values, so 0.62, I'll label that 0.62, and over here would be 0.67. Doesn't have to be exact, I'm just trying to get a picture. Okay, I know it's going to be less than half. So the probability of 0.62 being less than p hat being less than 0.67 would be, now we need a normal CDF, don't we? Normal CDF, we're finding the area under a curve. From 0.62 to 0.67, mu sub p hat is 0.6, and sigma sub p hat is, I'm just going to put sigma sub p hat because it's right there, isn't it? And we'll put that in our calculator. All right, so we go to our distribution, our normal CDF, and we put in 0.62. You got to put the decimal or you'll get in trouble. Make sure the decimal's there, 0.67, then 0.6, and then go get our square root symbol and type 0.6 times 0.4 divided by 100. Close the parenthesis and make sure it's all right. I like it. All right, and we get 0.2650, 0.2650. Now that's a little off, but it's well within the 2% margin. I'm okay with that. The difference between this answer and the answer that you see here is very explainable by the rounding error in the chart, so it's absolutely fine. And you did it, didn't you? Yeah, you did that one on your own. Good job. All right, I think that was the last question. So yeah, this first one, something's not quite right there. I don't have enough information to actually have a problem. Okay, I'll try to get this posted and out to you. Take care, Cheyenne. Please let me know as you're having problems. All the best.